We are live. You can go ahead. Thank you.
Okay, thank you. Okay, welcome everyone. It's my pleasure to introduce today to you Cherry. Sorry, I butchered it now. Sorry, and Teresa Vigas, who are coming here to tell us about the Cradle of Life with SKA. So Cherry is actually the co-chair of this SKA Cradle of Life working group. She's currently based at CNRS in Orléans, where she is a permanent staff researcher. But she did her education, her PhD, actually in Germany, in Bonn. But her first research encounter with astronomy was actually in Spain, in Madrid, where she did a project with Maria Diaz Trigo on XMM Newton. Her personal science interests are fast transients, pulsars, fast radio bursts, and SETI. Teresa is representing the team that is coordinating the Spanish participation in SKA. She is based, or well, not based, she is affiliated with IAA, I got that right now, and she's a member of the team there. Originally, she got her PhD in the University of Manitoba, and her research interests is focused more on galaxy radio halos and their magnetic fields. So Cherry will start, and then Teresa will join in at some point. So please go ahead.
Okay. Okay, already. Thank you very much, Siska, for the introduction, and thank you so much for inviting me here. So today I would like to tell you about the Square Kilometer Array, the SKA, and the Cradle of Life science. See? Yes. First thing. Okay, so first of all, in case some of you don't know, but anyways, sometimes this number keeps changing. Let's take a look first. What is the SKA? The SKA, it's actually has two parts, like two telescopes. It's got one part, the mid in South Africa, and the low in Australia. Let's see. The South African part, we can see a drone. Well, it's a simulation, really. It is not yet built, and it will look like this. It has almost 200 steerable dishes, like about 50 meters in diameter, in the Karoo Desert in South Africa. Australian part, let's see. It will have 131,000 of these tree-like antennas that are grouped in so-called these stations and spanning a really, really large area in the Western Australia, also a very remote places that is very RFI quiet. The SKA is supposed to be the most sensitive radio telescope ever constructed, and is going to deliver transformational science. Currently, the SKA has 14 science working groups, as you can see here, and it will provide many answers of key astrophysical questions that we have. For example, it will produce a 3D map of the universe and teach us about dark energy. We can study the ISM, learn about star formation, and the galactic center to see how it impacts the evolution of our galaxy. Cosmic magnetism will learn how the universe become magnetic, where and how did it all originate. And we will be able to detect all the pulsars that are beaming towards the Earth and find the right system to test Einstein's theory of gravity. We'll be able to observe the first galaxies in the era of cosmic dawn, and of course, seek the answer of origin of life with the Cradle of Life science group, and that's what I want to talk about today. But before going into the science, I did a little statistic to check how many people are in each of the science working group. I thought maybe it is an indication of the level of interest, at least. And we see, okay, cosmologist is the clear winner, but Cradle of Life is not far behind. It's definitely one of the big science working group. And I'm happy to say that during my week of Spanish tour, we have successfully recruited 3 more members. And so maybe after today, we'll see more. Let's see. Within Cradle of Life, currently 142 members. I made a chart of the distribution of the people from which countries, and we see that it is quite even. It's nice, and there's no dominant country, and Spain is now jointly as large representation as the Italian. Now, if we look at the Spanish people that are in Cradle of Life, we'll see that the most people indeed come from here. So I'm definitely in the right place. The IA also has a strong contribution, and we see also people from Madrid and Valencia. Anyway, so here a little bit cut off. Let's see if we can put this somewhere else. Okay, just about. So if you are interested to join Cradle of Life or any other science working group, then contact Teresa. But if you want to join Cradle of Life, please send me an email and I will put you in the mailing list. So in Cradle of Life, as I mentioned, we are interested to find the answer of the origin of life, but this is really, really broad because a lot of things fits into this bucket. I will tell you a little bit more about a few of the topics. One of the key one is the planet formation. From ALMA in the last year, we have seen these stunning images of protoplanetary disks, and we have been able to observe these concentric rings of dust and gaps. And this really fits into our understanding of the initial condition for planet formation. So it seems good, but in fact, if we look a bit closer, there are still many unknowns in this picture. We don't know exactly how these rocky planets can form. With ALMA, we have what we observed in these concentric rings are millimeter particles. They are really small, but we don't know how they can grow into rocky planets. There are a few problems here. One is that if we look into the lifetime of the disk, we see that they are supposed to be quite short-lived and not enough time for the planets that are at large radii to form. Also, there is a so-called centimeter barrier, is that we don't know how to form the centimeter-sized pebble. The particles, millimeter size, that we observe in the laboratory, we see that if we try to put them together, they will tend to break into pieces, or they will bounce off each other. So we cannot make them stick. Also, these particles in the disk, they will experience some kind of aerodynamic drag because of the wind from the stars, and it will most likely pull them towards the stars. So how did they even manage to become the rocky planets that we have ourselves? All these major questions is going to be answered by the SKA MID, the band 5 in particular, because it has the right frequency range to observe these centimeter size pebbles. We want to see where they are, at which stage they are formed, to better understand this picture. Next one is molecules, in particular amino acid, because they're key ingredients for synthesizing proteins in living organisms. Now, amino acids have been detected in meteorites and comets. So we think they should be there in the ISM as well, but it has not yet been detected because it's really hard. So it has been suggested that perhaps we should look in the very coldest place, and perhaps in the protoplanetary disks, there are these molecular clouds, and there are these ice, which is then protected from the interstellar radiation. Maybe molecules can actually form in these cold places, or prestellar cores, which is another colder region. Once again, we would like to use SKA MID, the band 5, which has the frequency to probe these cold regions. Next. Magnetic field of exoplanets. Now, studying magnetic field is very insightful because it teaches about the planet interior and the dynamo process. And this is, in fact, how we learned that our Earth has a liquid core. We also want to study the magnetosphere because it can protect the planet from solar wind and it has then implication for habitability. In fact, our own Jupiter is extremely bright in these decametric frequencies. So we can expect that an exoplanet, if it's like Jupiter, it would be so bright as well, and we can observe it. Now, I have to say, it has not yet been observed, magnetic field from exoplanets. Now, there are also hot Jupiters. As we know, there are many hot Jupiters, and which means that the Jupiters in exoplanet Jupiters, they could be even closer to the sun, which means even stronger magnetic field. For this study, we hope to use the SKA low, which has lower frequency ones, and we need the low frequency to study the magnetic field, and we also need polarization information. One more key science is SETI, the search for extraterrestrial intelligent life. Now, only a very small fraction of the sky have been searched systematically for SETI so far. And we are very excited about SKA and NGVLA, both of them, these next generation telescope, because they are the first time we have the enough sensitivity to detect the so-called leakage transmission, which are transmissions that are not specifically directed to the Earth. That is maybe the TV channel or the radio of this extraterrestrial civilization. They're just broadcasting. SETI research has very much been supported and driven by the Breakthrough Listen Foundation, and the headquarters of which has last year moved to Oxford, partly also to facilitate a closer relationship with the Square Kilometer Array. We think with the SKA, we need sort of commensurate strategy to search for SETI, because that would give us a really high sky mapping speed. We want to be observing all the time. In fact, we are already conducting Pathfinder projects, SETI projects on Meerkat and the Very Large Array VLA. And these projects are really giving us key knowledge for how...
Hello. I don't know.
They're giving us key knowledge of how we are going to do the same search, but much more sensitive with the SK and the NGVLA. Well, Cradle of Life is so much more than just those 4 things, but I don't have time to talk about it. In the last few days, I have met a lot of new friends, and they told me about these exciting research that they are doing in these topics. And I'm hoping to meet more new friends in Barcelona that I will learn from you how the SKA can be useful for your science. So please come talk to me when you have time today, and tomorrow I'm here. Now, Cradle of Life, what have we been doing as a science working group? In 2015, there was the coordinated effort to write the white book. 2021, there was also more writing going on, the scientific use cases. And since then, we've been doing sort of Zoom talks and webinars. They were mostly during the pandemic period. We had these monthly talks, which were well attended, but it's been a bit difficult after the pandemic because we prefer in-person talks, right? We tried doing sort of joint discussion with another science working group because we see that commensality, the synergies is really important for the SKA. So let's try to talk to another group. We did something with the Our Galaxy group. Yeah, that was pretty successful as well. And so I think we should continue the momentum, but maybe meet another group next time. We are also currently organizing some demos from the SKO. The next one coming up is we are asking for a demo for the sensitivity calculator, which I'm going to mention in a bit, actually. Anything else, if you want to see or hear particular things from the SKL, let us know. We will organize it for you. And perhaps in-person meeting, we just talked about it a little bit this morning. If there is interest for it, we can definitely do that. We could also tag onto other conferences. I know that there's an SKA conference in Germany in 2025, but it could also be, the SELF conference. What's the last thing here that is being covered? Yes. And perhaps it's good time to start to think about writing the proposals again. And yeah, I say again because it has been done already before. From my Google search, because it was before my time, I understood that in 2019, this has already been very clearly thought out. There were two main suggestions for the Cradle of Life. We have came to the idea to do two key science projects. One is a deep field for the young stellar cluster, and the other was a more sort of survey type exercise with the SKA law to study star, planet, and civilizations. I think it's the time for review. We should get together again and see if we want to update these key science projects and see if there are new ideas since the field has evolved, right? And this is and we started doing a bit of that. We got in touch with the Galaxy group. We had this Padlet web platform where everyone could go and post comments and like each other's ideas. So we had a few nice inputs from various people. They suggested, well, this is kind of similar to this is the original idea, the large-scale survey, but some people suggested, well, galactic plane, or work with the pulsar people, or the galactic center, the comets. Yeah, so we should keep doing things like that. Rainer, for example, during this Padlet exercise, came up with this science matrix where, for example, we've listed the key things of Cradle of Life, and let's see which other groups might be interested to see which are the common boxes. So, yeah, back one. So this is great. And we are starting to work on it again, but maybe some of you are thinking, well, SKA is still a long time ahead, so I don't have time to work on thinking proposals. So, and I'm here to tell you that's not right, because the SKA is being built. It is really coming along, and I have collected some really updated photos of the constructions to share with you. They are from the last few months. First, some updates from the low site in Australia. These are some Google images, Google Earth images of the sites, and the green spots are the stations. And currently there are 4 stations being developed, and they're marked here as 8, 9, and 10. And zoom in photos, and you can see that the site has been cleared of trees. And these are some more the photos of the actual constructions being done there. You see that they're spraying water because there are a lot of dust. And they're putting the mesh down and leveling the ground, making it flat. They are doing heritage monitoring, which means that they are walking very carefully on the site to make sure there are no artifacts from the indigenous people that should be preserved. And we see also a photo of the SKA staff deploying a test array, because this is not the actual station, but they are putting these antennas together in different configuration to test the layout to see if there is one that makes less crosstalks. So from South Africa, we see once again a similar image, but now the green dots are the dishes. We see also some black squares, and those are the meerkat positions, meerkat dishes positions. And some of you know, the meerkat telescope will be fully incorporated as part of the SKA. So it will be, so the meerkat positions are going to become SKA too. Well, relabeled. Some photos from the top left, we see the first SKA dish being assembled in China. So it's contracted out to a Chinese company that is building them, and they at the end of last year assembled the first one together, checked that it was all good, and shipped it to South Africa. And here you see bottom left a photo of the wrap pedestal, which has arrived in South Africa we see a photo of the contracted camps that is built for the workers, and another photo from one of the mid sites where they are preparing to assemble the dish. And so here is important plot of the timeline, the major timeline. As we see, well, construction started in 2021, but really the last few months have made a lot of progress as we saw the photos. We are here at the red arrow. And this year, it's another milestone. 2024 marks the start of science commissioning, which means we are going to test, well, they are going to test the telescope, make sure it is working. Then 2027 is another important year. It will be the start of science verification. And this is when it will test that the data has the right specification for the scientists, and make sure that all the modes are available. Then another important time to remember for the key science project, planning and writing the proposal will be between 2027 and 2029, when the observations will actually start 2030. And in fact, the PI-led programs will start before. We will get to use the PI-led, we will get to propose PI-led project already 2028, although it is shared risk. Yeah, this is interesting to remember the fact that PI-led program actually starts before. And as we know, the SKA, this key science project is going to take up a lot of time. So in fact, if you have a good PI-led project, it is wise to do it in these 2 years when the KSP is not yet being too busy. I've annotated on this chart also different AAs. These are the array assembly stages of the telescope, because the SKA is now expected to be delivered in stages, and they are calling this array assembly, the AAs. And each AA has the implication of different number of dishes. So each one is progressively more dishes and more antennas. Yeah, so we see here, we currently, the photos we saw, they are building AA 0.5. So it is 4 stations in Australia and 4 dishes in South Africa. Then it will be AA1, just has more stuff. But important to remember is AA2, because AA2 coincides with the science verification. So if you have some data from science verification, they will have the AA2 configuration. Then the next most important one is AA star, because this configuration is what we will have for all the projects. The PI-led and the KSP will be data from AA star, which has almost all the station dishes, as well as all the Meerkat dishes will be incorporated. Now the SKA, that the design baseline that we saw at the very beginning of the talk, of which some people know as SKA1, is not, we do not yet have full funding for it. So there is no timeline for building this design baseline that you saw in the beginning, and this corresponds to the AA4 stage. Now I also annotated some key points for having data. And so we already said some of it, but just to be really clear, in this year, during the science commissioning, it is possible to have some test data, but we're probably not doing science with it. Now in 2027, this is when the first data, there will be some amount of data released to the community during the verification stage. In fact, the SKA will be asking scientists during the science verification for what are the good sources to observe to do the verification. So data will be released, but to the community. So nobody is going to own the data. Everybody will see it. And finally, operational data corresponding to these proposals will come as soon as 2028 when the PI-led project starts. Okay, then I have a few more technical slides about the array configuration and how it evolves from one AA to the next AA. There's too much detail, but it's just to give you the visual. So you see now AA2, you know, remember AA2 is science verification, and this has this is the dishes that we'll have in the mid. You know, AA star, this is when all the proposals, with all the proposals that we will write, we get AA star data. And you see they have the same baseline, for example, but it has more dishes. And finally, this is SKA1. And you see AA star, for example. Okay, let's look at this. Look at it this way. In AA star, this is the data that we are sure to get, 28 or so. It's about 73% of the full SKA1. And here it's a table of the receivers that is being built for the mid array, band 1, 2, and 5. And I note here that the band 5 will only be installed on the 50-meter SKA dishes. So they will not be retrofitted to the Meerkat dishes that are incorporated to part of this. Okay, these are all getting very technical, but just put it in here so that you have the information. And the same diagram for the low, we see the evolution of the stations. Okay. Like I said, those are all very technical. For us, we really care about is what those configurations mean for our science. And we want to know the resolution, the sensitivity. So SKA has very recently released the sensitivity calculator, and this is going to answer the question. And you see we can choose mid or low, and we have all these buttons. For example, we could here select the sub-array configuration. Now you can say, oh, what about AA2, AA star, what is the data that I will get from each of these stages? You can also select more options in the continuum button, the zoom window button. There are some more advanced settings, and finally you click calculate, and it will give you all these numbers for you to decide if this is the right thing for your science. I also already mentioned briefly, we are arranging a demo by the SKO to really walk us through this calculator, how to use it. And so if you interested to see specific aspect, please let us know, and we'll make sure that the SKO show us how. Okay, then really we gotta start thinking about the proposals. And so I have a lot of text, but I think it's important to read about it. So what are the proposals that we can write, and who has access to the data? First, let's look at the types. There's key science projects, and these are the largest program that require a lot of time, which means more than 100 hours. But this is not a hard cutoff. They are still debating it. Just a lot of time is saying, and resources that it needs to be done over multiple cycles. And we are saying one cycle is 1 year. Okay, and these key science projects are expected to provide added value data product and tools back to the SKL. So when you make a key science project, you have to actually say that I'm going to provide these tools back to the observatory, back to the community. Then PI-led project. These are smaller programs, within one cycle. And here you see a pie chart of the rough division of KSP and PI-led. Then there's a director time, target opportunity. We are quite used to this, I think. A long-term project, which is a bit funny because the long-term project is the one that needs more than one cycle, but does not qualify for KSP. Okay, then there is joint project, which is those that need both low and mid, or coordinated project, which is those that need SKA and something else, another observatory, another telescope. Okay, let's look closer at the KSPs. KSP, they have to demonstrate extremely compelling science. And currently they say that it can go up to 5 years. So I don't know, if you said 1,000 hours, divided by 5 is 200 per year. Maybe they will let us. I don't know. Then key science project, it needs a leadership team to oversee the delivery of the science outcome. And this leadership team cannot be more than 10 people. And one of them is the main contact. So this is kind of like PI, but anyway, the leadership team is only for member countries. Whereas the co-investigator, like the members, could be coming from anywhere in the world. There is a review process, the tech. Oh, no, this is not this. This is to say that the KSP will be reviewed regularly. And in fact, if your science goals are not looking good, they could terminate your project or reduce your time. The KSP proposals, it needs to include some stuff that we don't typically write in the proposal. So let's take a look. It needs a management plan, and we need to say exactly which thing is the 10 leaders doing in this project. We need to have a plan for the reduction and analysis of the observatory data product, giving details of any secured resources at the RC. And justification for non-members. Why are they in this project? And the number of non-members could be kept, but it is not yet said what it is. SKA has said that they will run at least one KSP planning workshop and issue a call for a letter of intent about 2 years before the first KSP observations. So that's, we already saw in the timeline, 2027 to 2029 is this. Okay, telescope access. Access and allocation of the SKA, there are these schedulable resources. What are they? That includes telescope time. This is that is standard. We understand this. But there's something else. There's computing resources that needs to process the data. And also the network bandwidth. These are our schedulable resources. And the next point is that commensal science, even though commensal science is really the power of the SK, but it's not free. So you can say that I'm gonna observe piggybacking this out observation, but it will also be counted against your member share. There are 3 types of commensal observations: data, observing, and multiplex. Data is when 2 projects use the same data for different science goals. Observing is when different projects use the same data for different data products. And multiplex is when you use the you just partial amount of the dishes or the stations, and while some other people using other parts of the dishes. So okay, just to keep in mind, there are these types: calibrated data, automatically generated by the SKAO. And these are the thing that called observatory data product, ODPs, but they're not raw data. We will not get the raw data. We as scientists will access these ODP via the regional centers. This data will probably require further processing, so we'll still need to do co-editing or do something else to get to the science we need. Okay, some more points here. Very importantly, no time has been allocated for any projects yet, and science working groups are not proto-key science projects. Although it is intended to be a forum for us to plan this key science project, they are not saying that, oh, yeah, Cradle of Life will give you a key science project. So we need to really think about the good science to make it a compelling case. Time allocation will be based on scientific merit and technical feasibility, while accounting for member share. So here is a summary table of what we can do as member versus non-member. For example, proposal leadership. So this is the leadership, the 10 people leadership team that we talked about. As member countries, we can do both. You can be a leader in KSP, you can be a leader in PI-led projects. But for non-members, they can only lead PI-led projects. KSP membership. So member countries can be in the leadership team and can be in the member, just be a member. So it can be anything, but non-members can only be team members. access. It's proportional to the member share. Depends on how much the country has contributed. But for the non-members, it will be capped at only 5%, and that's the open time, but still it should be determined by the council, and it may change. So we understand that it's very important to be a member because it gives us so much privileges. Fortunately, Spain is a member, so you are good. And I'm now going to pass it on to Teresa, and she will tell you more specifically the Spanish participation in the SKA. And you have this, I'll change the slide.
And don't worry, I just have a few more slides to kind of show you the more national situation, how we ended up in this, a little bit of history. And how do we move this thing? Because I particularly want to show you that
You can move with this thing.
let's put it up in the top here.
Yeah.
There we go.
Maybe also.
So this is the view of the membership that yeah, I think it's less in the way there. This is the view of the membership that SKA has. And if you notice down here, there's a little red star under Spain that signifies that we're full members. Okay. And that happened in April last year, and the IDO, the Intergovernmental Organization Treaty, was being signed. Now, why have you maybe not heard so much about this? Because this is actually a rather big deal. Okay, and what happened there?
Just because we moved the bar, so we need to click, and now it's activated.
Okay, perfect. So it was signed in April last year, but there is one formality left on the Spanish side. The signature has to be approved to be fully finalized by the Parliament and by a special commission, the Foreign Affairs Commission. And then there was an election last summer. And so all the commissions were dissolved, and the signature was kind of left hanging. So we are members, but it has to be approved. So formality. So what happens when it is approved is then that's when we will have a big ceremony, and you will be going to be sure to hear about this. Okay. So we were, however, members of the SKA organization back in the day before it was formed and made into an intergovernmental organization. So some of you might think, weren't we already members? And that is actually true. But then SKA was transitioned to this intergovernmental organization that requires a treaty to be signed. And this is actually only the second astronomical intergovernmental organization in existence after ESO that formed in 1962. So it's about time we have another one. But this didn't just happen just like that. Spain has been actually involved from the very beginning. When the SKA was conceived in the 1990s, to be exact. But then in 2011, we were involved in the way that it was actually funded. And this is when my boss, Lourdes Verdes Montenegro, who has been heading the involvement of Spain in the SKA from the start, PI'd the feasibility study of the Spanish participation in the SKA. And then the REDSCA, the network, which consists of a number of institutes, including ICE, was formed and has been renewed 3 times. And we have been directly supported by the ministry since 2020 and been doing all the work that is in this box to support academic groups, the industry and the ministry, as well as outreach, both to the general public and in particular to the astronomical community. Now, Spain is also involved in the design and construction of the SKA. So we are not only part of 8 of the 12 design consortia, but each country who is a member gets pre-allocation of industrial contracts that is directly proportional to the input you give with your membership. And so we have 5 pre-allocated contracts, of which 2 have been granted so far. for both sides. But apart from the pre-allocated ones, there are also operation contracts where another 2 have been granted, including a reverberation chamber for SKA low, which is all kinds of stuff to test the equipment for radio frequency interference, which is something that becomes more and more important these days. And now this slide I took from Philippa Hartley of the SKA, because people always wonder, well, how much data are we talking about? And at the facility, 2 petabytes per second of raw data will be stored for 2 seconds. We cannot store these data as we're observing, because there simply is not enough space. And then it goes directly through pipeline. And then up to 1 terabyte per second combined data stored for 2 weeks, also at the facility. And then 8.5 exabytes of data will be archived during the initial 15 years, where just these numbers don't make any sense, right? So 5 exabytes are all words that are spoken by human beings. I'm not sure how true that is, but just as an idea. Or another idea was that per year, the SKA will make as much data as the entire internet as it was in 2017. So I'm not saying that anymore because it doesn't make any sense anymore either. Anyways, so to deal with these data, you can't have it you can't do it the normal way. This is a complete new setup of how we handle data and how we work with it. So SRCnet is a network of SKA regional centers that is being designed to deal with the immense amounts of data. And there is one in Spain. It's the Spanish prototype of a SKA regional center. And it's currently operational. You can apply for having your project there. And it's mainly used for precursor and pathfinder data right now. And there is continuous development, continuous, for instance, the Slurm cluster has just been initiated there, so that the Meerkat pipeline that was developed in South Africa, the IDEA pipeline, can be run, and I'm just longing to throw some Meerkat data in that pipeline as soon as I come back from this. I'll probably be quick because we are out of time here, but I just wanted to say that here are some of the activities that the SKA coordination team are doing. There are meetings. Just last year, we had Synergy meeting, Open Science School, smaller meetings, larger meetings. We are frequently in the news lately. This is the Contact magazine, but I kind of like to advertise a little bit because I know that many people don't bother reading it maybe, or don't even see that it's there, but it's a very nice magazine, and Spain has been featured a fair amount of time. For instance, there's an article about how the regional center got a grant to develop open science and green computing. There's visits like this one with Sherry coming to visit you and other institutes. Upcoming radio astronomy course, Red Sky will have a meeting this spring, and there is a national website, and it's upcoming. Just like the SKA Spanish membership and the SKA, this is just one little formality left, and it will be online. You've already seen this. We are going to observe and learn from planetary to redshift of 30. And all the science is best accessed through the white books. So there is the SKA white book. Actually, there's 2 volumes. And this is my colleague, Mary Lou, who's a fairly normal sized person carrying one of the books. And there is the Spanish white book that was written in 2015 with many chapters, 29 chapters of all kinds of science that Spain is interested in and contributing to, and cover most of the key science areas. And here's just the Cradle of Life chapters. And just before this one, there's a chapter by Joseph Miquel about magnetism in the ISM. Now, it's been a few years since 2015, and a lot of things have happened along the way, especially with science results from Meerkat, etc. So there will be a dynamic upgrade to be discussed of the white book. I'm not gonna linger on this, but because you've already seen this with the science working groups, what I wanted to emphasize here was that join a science working group if you haven't already. It's the best way to stay in touch with the SKA science. And we have the perfect person to talk about the Cradle of Life Science and Working Group right here. So there, I'm going to end and just saying that the key points that you might want to bring with you is that the SKA Observatory is building the largest radio telescope in the world. It's not far on the horizon anymore, it's happening right now. And Spain is full member of the IGO, barring one formality. The timeline that has been evolving a little bit along the way, as things tend to do for really large projects, has been fairly steady with science verification in 2027, PI-led proposals 2028. And so it's time to start preparing both these and the key science projects. The sensitivity calculator is online, and the coordination team that is led by Lourdes at the IAA, that consists of people around Spain, works with the astronomical community to prepare it for the scientific expectation of SKA, and join a science working group. And contact me if you want to know more about Spain in the SKA. Thank you.
Okay, so thank you for a very enlightening view of the status of SKA. This has been very informative, I think. So are there any questions from the audience?
Yeah, you talk about the antennas deployment, right, with time, but the key part is the accelerator. What about the accelerator? Is already decided, it's already being constructed?
Well, on site, you mean? Yes. I'm not an expert of the correlators, but yes, I mean, the pipelines are being formed to handle the data as it comes in. I mean, it's a major part of the construction.
Correlator itself, no, okay. That is an important part, but I can speak.
I do
need to ask someone else.
I do have slides on it somewhere, but just not super accessible.
Yes.
Thank you for a nice talk. So I was wondering that we were talking about like very low frequencies, and at that RFI chemical resolution, right? So is it possible that in the sensitivity calculator we can have some information about RFI also for the particular bands? Like how much the sensitivity can be affected by RFI so as to like make a stronger senses?
Very good point. I will pass it on and make sure it's discussed at the demo.
Other questions? Yes.
For the science and the first thing, right? Do we know what is one future and one way to go there?
No, normally that will happen as science verification. I think the commissioning, it's not really to make observations, it's really testing the system to make sure that there is no bugs. So yeah, it was not, it has not been said that they want to ask about what to observe.
The commissioning observations are happening here.
Starting this year.
Yeah, exactly.
Yeah.
So they will start at some point this year. That's really very soon. Any more questions? Yeah.
We're talking about the access, the membership. It's not really safe now that we do it. But we're going to show the access of different things. We're going to have different queues.
Well, so the proposal, the telescope time, that one's easy. My understanding is that when you have a proposal that have different people, they will check the institute of these people. So you have one Spanish person, one French person, let's say, then the time is half these two countries. Now, what is not so clear is the SRC access, how that is split, but that is really a talk on its own. And I think it's not It has not even been fixed, the country's contributions on this SRC, so, you know.
This is something like this.
Yes.
Yeah, even the one you say, oh, this is easy, we just split according to number of people from each country. But, you know, whatever rule you put in place, people are gonna
Yeah.
game the system, no?
Yeah.
So if you don't want to penalize your home country, you put a lot of firm, you know, straw man on your proposal, no? You don't get a lot of, you know.
Yeah, but I guess that's why they said that you have to explain the role of each
If
person.
they're from other member states, then you don't.
You still
Only
have to explain.
the way you said it in your slide, it was only if they were not from any member states.
Maybe
I
let's see. I think I put it in here.
Justification for non-member investigators.
Yeah, just as justification, but there was something about the role of each of the leader has to be explained.
Leadership roles from countries.
A management plan, roles of each leadership team member.
Okay, but that's for the key science projects, but what
Yeah.
about the PI lab projects?
I'm not sure if the PI project have been defined fully yet exactly, but I would assume it's something similar to this.
Okay. Right, still some years. Yeah.
Right. One with this probing the cold regions to search for periodic molecules. Do you have ways to distinguish this peculiarity of the molecules? Or if it's some kind of molecules are what is their clarity?
Some help from the molecule people.
I don't know.
I can say something.
Yes.
I think radiation is very different. So yes, with the spectra you can do, but there have been some attempts to try to link reality with the environmental properties. So either with the radiation field or with the magnetic field, because it seems that depending on the intensity of the radiation impact, this can enhance certain populations of chiral molecules, so you can favor some reactions. But from the spectra directly, as far as I'm aware, so you can.
Would be something. Okay, and then the second question, so I understand that this project is already ongoing, everything is being manufactured, but for future versions or improvements, what would be the opportunities for making technological research? Improving antennas, improving, I don't know, later. Receivers, so how would it be possible for research groups on the technology area to participate?
I think it is a good idea if there's interest in that to try to be involved already now.
Are you aware of some of the contracts that have been, maybe that could be useful to hear about examples of contracts that have already been awarded and see what more could be done.
Well, especially for like the extension of the dams, yeah, no, it's a very good question.
Who is the contact person in Spain for the hardware contributions?
This is
Javier.
Julio.
yeah, no, Julio is not the person in Spain, but he's connected to a person in Spain whose name so inconveniently just slipped my mind. But yeah,
You can let us know.
I will let you know.
Yes. Also, I think what you're also asking is whether there are plans for an ongoing development program after, after you start operating the telescope, after you've built the whole thing in 2030. Do you actually have an annual development budget to add capabilities to improve the telescope, etc. Right? That's kind of what you're asking, right?
Yes.
Yeah.
I
Yes,
think,
but maybe to improve them, maybe some research has to be done right now, so.
Oh, yeah,
right, right.
I mean, there is plans, there is definitely plans, and the main lacking thing is funding, so.
Yeah, I'm more on the science side, so I don't know that much about the technicality, the hardware development. But I mean, at least we want to, if there is more money, we want to build more stations and more dishes because the original SK.
Yeah, extend the baseline.
Yeah, extend the baseline was supposed to be even bigger, so we haven't even reached that yet. So one could already do that, but okay, that's not a developing new things. I know another development that I am aware of is that SK is also very keen to make the energy as green as possible. So to develop renewable energy as a source, and they have suggested that they would like to reach the target of 40 to 60% being renewable energy at some point. And this is not something we have done yet. So this would be another thing for the future.
So that requires actual research and SKA was from the research then, or only the building and implementation.
Not have the details.
Yeah. Okay. All right. Are there any other questions?
There's a question online.
Okay. Yes. Go ahead.
Yes, thanks. It's Claudio Codella here. Thanks for the talk to both the speakers. I have just a naive questions. Maybe you already, I just missed this point. Is it possible, it will be possible to observe simultaneously lines and continuum?
Yes.
Okay.
Just like with Meerkat now, actually, that the spectral resolution is fine enough, so you will get continuum as a byproduct when you do line observations.
Okay. Thank you very much.
Okay. Any more questions online, or that's it?
Yes, I'm curious about the safety project. Given the very big amount of data, is there already a strategy for looking basically for signals in terms of which targets to look or fraction of time dedicated to it? And then the second question that is related to this, if you take the Earth as an exoplanet, with our amount of noise, of radio noise that we do, how far can we see such a radio here, such a radio leakage, more or less? Have you any idea?
Nice, because we had a similar question on Tuesday. So it's a very good question. Okay, part one, SETI. So yeah, a lot of data, but I think the way to go is really commensurate observations, because for SETI, well, we don't have a specific target. We just want to survey as many stars as possible, because I didn't show more detail. I did talk about it on Tuesday though. It was not recorded. Yeah, it
Yes, it was recorded.
Yes,
Yes.
the Granada talk was recorded, but I talked more about the SETI part. So I guess I can share the link. But the fact is that we have only searched a very tiny part of the sky for SETI. So we just want to see, it's very possible that there's something out there, but we simply have not looked. So I think the first improvement is the sky mapping speed. So we need that. And so the best is to commensally observe with some other people, because anyway, we don't care where to observe. So that would be a win-win situation. Now on Meerkat and the VLA, we are already doing that. So Drexel SETI Institute have funded a dedicated SETI backend that we deploy on site. We make a copy of the data, and then we are just observing as whoever primary observer, and we analyze the data. So that's working pretty well. I think for the SK and GVLA, we should do something like this, but we haven't thought about it. Well, we're not at this advanced stage yet. I'm not sure if we could deploy SETI equipment on site, or if not, if we can we process, because the observatory data product will not have the fine resolution that we need for SETI. We really need very high frequency resolution of like 1 Hertz, and nobody in astronomy does that. Because why? It's because we try to look for very narrow SETI signal in order to differentiate from anything astrophysical, because astrophysical signal are typically more broadband, sort of megahertz, several hundred megahertz band, and so we think if we detect something that are much narrower, then we have more certainty that it's not something else. So we need that, and at the moment, this is not yet available from the SKA, so we still have to see how it works. What was the second part of the question is if the Earth seen from outside. Yeah, indeed, we have not really been careful about our footprints, like we're just broadcasting everything. So, and as we radio astronomer knows, in our data, we see so much crap. And so these are all the stuff that someone else could detect if they try. And if these extraterrestrial intelligence, they have much higher technological capability, they can see this stuff. So, but how far, this is a very hard question to answer because it depends how good are their detectors.
But if they have an SKA?
If they have an SKA.
If there is an RC sending out a radar signal.
Yeah, well, I think we said that the SKA can detect sort of airport radar from someone else within 60 parsec. So maybe we can put it the other way around. So.
Okay. All right, are there any other questions? Okay, if not, let's get sharing in today's again. And to those of you who are joining us for lunch, you know who you are. Let's meet in just a few minutes at the front.